All right, now let's actually get into the training of the model. So just between the last video, I just played like 4 rounds against Margit. Um, yeah, I didn't. Here we're going to encounter the most fundamental problem so far is one, not enough data. This is a much harder task than something like driving. And two, not enough good data. Pretty much anyone, or I mean, not pretty much anyone, but I played all of GTA. I feel pretty confident that I could drive for an extended period of time in that game without worrying too much about crashing. I can go really fast. I won all the races, whatever. But I'm not that good at Elden Ring. I may have beaten the game, but that doesn't mean I can beat Margit easily, regularly with a level 1 unupgraded club wretch build. So there's a challenge right there, right? Is that ideally I would be super good at this game. I would go in, I would beat Margit, but I wouldn't actually beat them because you want to generate a lot of data. So you'd go in, you get them down to 1 health or 1 attack, and then you jump off the cliff and die, and then you repeat this process. Um, so I guess if anyone's really good at Elden Ring, they can do that, but I am not that good. So that's the first problem. The second problem is, oh, sorry, I guess that's the second problem. The first problem is the amount of data. The final problem, the third problem is that these are extremely imbalanced data sets. Um, so, for example, WASD are pressed pretty constantly. Space is pressed regularly, but you press R, I don't know, 4 times maybe, right? If you have 4 flasks, you're going to press it 4 times for a split second. So, the number of W's presses is, 10,000 to 1. So it's very hard to get it to either learn to press R or not, or balance it basically. So use potions. For example, I had an earlier model that I was working with, and I was like, it's not learning to do anything but press W. So I adjusted it, and then I was like, it needs to learn, these less common attributes. So I adjusted it, and then it only pressed R. So, there's that. But we'll get into that right now. Um, so we're doing this all in TensorFlow. I thought about using the base in Centex's original code. He used like what's it called? AlexNet base. I could do that. I don't know if that's the best strategy. I'm not super familiar with the computer vision world right now. All of my experience comes from the deep RL world, where like within the last couple months transformers have entered the equation, whereas that came out 6 years ago in NLP. So the sort of advances are kind of slow to catch up to deep RL. So if someone's like, oh, this is really easy, you want this, you can do this. All of this code, of course, you can play with. All of this experiment tracking is done via weights and biases, which I have slowly been converted to over time. And if you want access right now, I'll show it at later. You can see all the runs. Anybody can look at them, but you can't add runs. If you're like, I want to contribute to this project, just message in the Discord, and I have no problem like adding people. I just didn't want to make it completely open. So yeah, we have our actions and we have our folders. We create our we read from these folders. So yeah, basically we just go through and read from them, creating the so reading in each of these images. And then what we do here is basically we want to frame stack them, right? You need momentum information. Is pretty standard for this sort of stuff. Is we could either have some sort of LSTM at the center of this, or recurrent thing, or God forbid a transformer. But another way to do this that's common and very efficient, much more efficient in the RL community, is just by frame stacking. So you don't really, that sort of maintains some sense of Markovian properties. But the way we frame stack it is we take our data, which is just the one frame after another, we stack them on top of each other. We add an axis that we're going to be frame stacking on. We rearrange it. So this is right? So this currently is our batch height, width. I don't know. It saves it in the opposite that way that we want. And then this is our new axis. And so we're keeping this one, and then we're just swapping these two because the way it's saved, the way OpenCV like manages it, swaps the axis. It doesn't really matter. And then what we do is we say, this is our data, right? This is what we have. We're concatenating here. Basically, we have this shifted. So we have this first, if I do this, we have data 1 equals this first one repeated, basically. So we have, if our like original way, maybe I'll do this, just pretend this is the original array, 0, 1, 2, 3, 4, right? So that's what we're frame stacking. So the frame stacked version, right, would be 0, 1, 2, 1, sorry. Yeah, so I guess it would be 0, 0, 0, 0, 0, 1, 1, 0, 1, 2, 1, 2, 3, 3, 2, 3, 4. Right, so at the beginning you have no frame stacking information because there's just one frame, and then you add more and more. So this is 5 length as well. So what we're doing here is we're saying, okay, we're doing 0, 0, 1, 2, 3. Data 2 is 0, 0, 0, 1, 2. And then what we're saying is we then make the final data equals to, we're concatenating data 1 and data 2. So this is the interstep is 0. So we're saying take this, the original one, concatenate along this middle axis, which I'm just, invisibly putting in here. It's 0, 0. And then we have 0, 1. And then we have 1, right? So this concatenates that. Oh, this is also the wrong way, I'm pretty sure, but it doesn't actually matter as long as it's consistent, as we want. See, so this first frame, right? So it'll be here. Yeah, so this is actually the way we want to do it. We would want concat this to this to this. And then this to this to this, and then this to this to this. Okay, well, but we'll just leave it for now. I can change this. It doesn't really matter. The reason I say it doesn't matter is because as long as it's consistent, right? The neural network doesn't know which way's forward and backward in time. It just knows everything's this way, everything's that way. It doesn't really matter. So I'll leave it at the way it was originally. Then we shuffle the data and the labels. We print the shape of this data. So in this case, the data was 3,800 was how many I was training it on here. Just in case you were curious. And then the excuse me, sorry, I was just coughing a little bit there. And then the parameters we have here, we set our learning rate, 3, -4, how long we're doing this. We have early stopping, so it doesn't really matter what validation training split we're doing, how big our batch size is. And then we split our data, of course. We create our data set. For those of you more experienced with training large data sets, this place could certainly be optimized. I'm looking to create a better pipeline for training with large amounts of data that you can't just load into RAM. So I'm looking at, I simply with RL and stuff, you don't have to worry so much about that. So I'm looking into Obviously, you can't load like all of ImageNet into NumPy arrays in memory, so I'm looking at that. But if you have experience, your input is very much welcomed here into creating an effective training pipeline, data pipeline, basically. Then we have our inputs, which is our 244 by 138 by our 3 frame stacks. This is also where I welcome input. This is a neural network that I copied. This is basically the same one that's in the Nature DQN paper. But I don't know if that's good or not for this case. It's very small. It's about 4 million parameters in this case. As opposed to, the AlexNet, the VGG, all the other ones, which are at least, 10 to 100 million parameters, depending on the size. And then we have so this is just a convolutional neural network, right, with dropout to prevent overfitting. We have a sigmoid activation at the end because they're not mutually exclusive. We don't want to do a softmax because our actions can be done at the same time. We create our atom learning rate. We have our binary cross entropy for each one, right? It's a binary yes or no is a key pressed. We're keeping track of the accuracy, how often it gets the key pressed correctly. We're initializing this project or initializing this run in the project after we compiled it. We're checkpointing it. We have early stopping when the validation loss doesn't decrease. We save the model every time the validation loss does decrease, and we have our weights and bias callback. And then we have our class weights here. So, right, I said the data set was extremely imbalanced. So we have to balance it some way or else it's never going to learn to do certain things. And the way we balance it is by artificially weighting classes. So we say this class counts X amount in the loss function. So, if you're minimizing loss function, you're not just going to minimize one way because it's multiplied by some bigger number for the less common values. And the way we do this is just directly inverse of how common it is. So if this is a very small number, then this is going to be a much larger weight assigned to it. And then we just fit the model. So now I'll actually share the. Now I'm sharing the weights and biases thing. You can't see the project just because I changed the team settings, but these are all the runs we've done. They're very small. This is just setting it up for the future. You can see if I hide all, if I just do visualize none, this is the most recent example of the sort of plots that we're tracking. So visualize all and then get rid of this one. Yeah, so this is just an example of how we're experimenting, tracking. You can see there's a lot of work to go. These are all pretty bad right now, but that's the basic idea. So now that we've gone over how to train it very quickly, lots of room for improvement. I welcome suggestions and collaborations here. We can actually go over to running it. So now the reason this is the funny part is the reason I say, OS environment hide basically my GPU is although it's faster to train right on my, 3060 or 3070, whatever it is in there, it's pretty good. It's pretty fast to train neural networks on them. Inference is very fast. The problem is if I boot up Elden Ring and use my GPU for inference, I get terrible FPS. I get like 0.5 frames per second because Elden Ring is taking up all of my GPU, and so allocating that neural network on there is very slow. If I do it on my CPU, I can actually get about 20 FPS, which is very good. So once again, we have the same key press that I talked about in the previous video. We have our neural network that we load, and then we do a one forward pass just at the beginning so that it builds the graph basically, and then the next forward passes are fast. We copy this exact same code from before. I do if max health equals 1, max health equals. That's just so I don't see those annoying errors. Oh, do I have to? Oh, I see. Oh. Oh, is this because I need to? Oh, I'm getting the classic indentation errors, you know. So I'm just gonna, there we go, fix those indentation errors somewhere. There we go. Oh my god, there's so many indentation errors. Okay, it doesn't really matter. I don't know why I'm getting these now. But okay, fix that. So basically, yeah, we just screen cap the image. And then transpose it. And then feed it to the neural network. And so the inputs, right, this is actually what we're doing is making sure we're doing the frame stacking live, basically. Inputs is a DQ, so it'll pop, right? As you add something to the end, it'll pop it off from the beginning. So I guess actually it does matter because this is a different, the oldest image is the front image. So yeah, I guess sorry, what I'm just thinking about here is that this is so the images here, right? We do basically, it's of the form newest, mid, old is like the frame stacking that's going on here, but this frame stacking is old, mid, newest. So what I'm gonna do actually is just go back here and fix this. I'll do data 2, data 1, data. There we go. And then I'm gonna retrain this real quick, and then we will be good to go. All right, I finished the training. In total, training, they end up going for about, this one went for 18 epochs, and that took about, I don't know, 20 seconds, maybe max. But this is also a very small data set. I do have a bigger data set sort of on my hard drive, but that is something to keep in mind, that I feel like there's a lot of room for improvement here, and I'm going to be looking into it, but I'm not the expert right now on how to improve this. So I did just do that run. So now I will go into how we want to interact with it. Actually, I realize I just did that. So we have our interaction here. So now we can actually do an example. So I will boot up the game. All right, I got Elden Ring up and running, and I did just do a test run because I didn't want, like last time, to happen. And the thing I'll note is that here you can see it moves a lot, but it doesn't actually do anything else besides that. I'm getting FPS interactions of 15. But a lot of times what you'll see, so you can see the actions down here that it's pressing every second, is right as it's dying, I is heavy attack, by the way, strong attack. So you can see that usually as it's dying, only then does it actually choose to attack. But basically what we're going to do is just go over here, get this set up. And so we want to get this properly, we get this guy in front of the mist. Let me make sure it's all recording. Yep. And then we go over here, run our model. We alt tab back over, and then once it starts giving the countdown, then we enter the mist. So it's going to do a little bit. Okay, now we're in here. So then we give it a little run forward, and now my hands are off the keyboard. It did just do an attack there. You can see it moves around. It's going to tank that nicely. You can see the buttons it's pressing, and it dies. You can see an eye there, meaning I wanted to attack. I'll give it another run, but I don't think it'll be super good. So yeah, this is basically the current state of the project. I made basically all of these videos at once, and this is where we stopped off. I haven't done any work on this recently. Hopefully I will be able to shortly, but this is sort of the state of the project. All right, I'll go into the mist. I'll run. I just like to give it a little run up. Sometimes it's more interesting. So you can see, once again, there's no dodge rolling. Yeah, so not much to comment on, not a lot, not super impressive or anything like that. But it's a start. The input's working, the output's working, the pipeline is complete. There's just clear rooms for improvement that I've mentioned, that I'll be working on if anyone's interested. Once again, there's Discord, there's a GitHub, very much open to contributions, open to ideas. This should be super fun. I look forward to working on it. I'm going to explore the next steps, are sort of exploring data inequality in terms of imbalances in the data, generating more data efficiently, looking into other methods, getting more data, improving the neural network. These are all directions basically that I'm going to be looking at. So yeah, that's basically it for this video. That's the neural network training and running and the current state of the model.